Hey guys, in this video lesson, we're going to apply our knowledge of solving linear systems to solve some semi-realistic application problems. So let's get started. During the process, what we're doing, given a problem, our first goal will always be, let's turn our problem into math, into a linear system. Because once we have the linear system, we're well practiced up. We know how to solve a linear system. But what will be challenging for you guys, and which takes practice, is given a problem, how can you turn that into math? How can you take a problem, words, and turn that into a linear system that you can solve? So that's going to be the challenge. We're going to do some examples together. Obviously, it is impossible for me to cover every single possible type of question under the sun, but we'll cover in broad strokes, the types of questions you might see, and then solve them together. So it should be fun. So let's go to our first example. So in this example, and I think you guys would agree that, we're not solving the Earth's problems with this example. It's a bit of a fictional problem designed to get the ball rolling a bit. But me and Bryden like to disc golf, and I have 21 more Frisbees than Bryden has. In total, we have 37 Frisbees. So I've asked you to find, given that information, how many Frisbees do each of us have? So that's the problem. Now, the first step with these questions, always, if we're trying to take this problem and turn it into math, well, we need to choose some variables. In a linear system, we have two equations and two variables, often x and y. We have to pick what are our variables going to represent in these questions. And often our variables are going to represent the two things we're asked to find. We're asked for how many Frisbees I have, and we're asked for how many Frisbees Bryden has. So our first step is going to be assigning variables. Now you can use x and y. If you just like using x and y all the time, that's fine. In this case, I'm going to use variables that are specific to the context of the problem. So I'm going to say what's a good choice for me? I'll just say let m represent the amount of Frisbees Mr. Smith has. So write out a sentence. As you're doing practice and just whipping off lots of practice, maybe you can just do a little point form, for example. But when you're submitting work and you want somebody to look at your work, you should use a full sentence so we're absolutely clear on what your variable represents. Saying something like this, m equals Smith, that like maybe in your own mind, you can say, okay, m is the number of Mr. Smith's Frisbees. But in practice, m equals Smith doesn't make any sense. Like if somebody from another class were to come read that, they'd have no idea what you're talking about. So maybe if you're doing like homework, that might be okay, perhaps, as long as you understand what's going on. But in practice, when you're trying to show your work to somebody, when you're being evaluated, you want to put your best foot forward, use a full sentence. And let's use B for Bryden. So I'm going to let B represent the amount of Frisbees Bryden has. So now that we have our two variables, we need to set up two equations. And usually there are going to be two pieces of information that help you set up two different equations. In this question, we were told two things: that Mr. Smith has 21 more Frisbees than Bryden, and that in total that we have 37 Frisbees. Now, I actually think the second piece of information here is a bit easier to make an equation from. Now, if you're taking the course with me right now, in class, we might have did a bit of a warm-up where I gave the class, a phrase or a sentence and had them turn it into math. So thinking about, that, more than might indicate addition and the word difference indicates subtraction. But let's set this up. So in total, they have 37 Frisbees. Well, that means the number of Mr. Smith's Frisbees plus the number of Bryden's Frisbees has to equal 37. So we've turned that into an equation. Mr. Smith has 21 more Frisbees than Bryden. So there's several ways to write this, but we could say this. To get the amount of Frisbees Mr. Smith has, we take the amount of Frisbees that Bryden has and add 21. And we've got two equations, equation 1 and equation 2. Now, oh wow, that's bright sun. I guess we're just gonna roll with it. All right. Sure there'll be some cloud cover in a second. But we have our linear systems. Now, some advice to you guys. A lot of times I see students want to take all the information and just mash it all together in a single equation. No, just take one piece of information, make an equation for it. Take the second and make an equation for it. So now that we have our linear system, we got to solve the linear system. So I'm going to actually just rewrite the linear system up in the top left here. Now you don't have to because you're ideally doing this home on the lesson sheet, so you already have the equations written out. I think it was plus 21. Yep. And our total Frisbees was 37. Equation 2. So now that we set it up, you have to decide which method do you want to use here. Now, our variables aren't quite lined up, so elimination may not be practical here the way it's set up. Noticing that equation 1 is already rearranged for m, I think substitution is the best choice here. So you don't have to write this down, but I'm just writing it down for emphasis. Substitution would be great. This linear system is tailor-made for substitution. Let's sub equation 1 in equation 2. So m is equal to b plus 21. And the rest of equation 2 is plus b equals 37. And let's simplify this. So we have 1b plus 1b, that's 2b. I'll show a ton of steps. You could probably shave a few steps. Subtract 21 from each side. 2 times b equals 16. And then divide by 2, we can see that b equals 8. Bryden has 8 Frisbees. Let's find how many Frisbees I have. Let's use equation 1. Where's my cursor? Yeah, it's my daily. Where's my cursor? All right, let's go up here. Let's sub b equals 8 in equation 1. I think makes the most sense because it's already rearranged for m. M equals 8 plus 21. M equals 29. Mr. Smith has 29 Frisbees. Now you can do a quick check here. Is there 37 total Frisbees? Yes, 29 plus 8 is 37. Do I have 21 more than Bryden? Yes, I do. 29 is 21 more than 8. I know this is right. I've just checked my answer. It took me 10 seconds, right? You can use a calculator, but you can use a left side, right side check. But often just doing the mental math and just double checking is great. So we have solved the problem, guys. Now, usually, in most word problems, you should make a concluding statement. So it kind of just shows you understand what you found, what the solution to the problem is. So we could just make a quick one. Mr. Smith has 29 Frisbees. Technically, they're discs, so not Frisbees. Frisbees are the ones you like, the really big ones. But when we're playing disc golf, we're using like actual discs, and there's lots of different types. But I digress. Maybe we have some disc golf nerds in the class that I can chat with. But Mr. Smith has 29 Frisbees, and Bryden has 8. All right, and we've solved our first problem-solving question together. So just to summarize the steps, it's always, that sun is just annoying, but it's always the same thing. assign variables, make two equations, solve the linear system, write a concluding statement. And it's the setting up that you guys are going to need the most practice with. Because at this point, we've been solving linear systems for a long time. We hopefully have mastered all the methods, or at least we are, getting fairly proficient there. It's the setting up that is the new thing. So let's try another one. In this example, I am planning a disc golf vacation. So the first option costs $656. It's 8 days long, and this includes 2 meals a day. So 8 days plus 2 meals is $656. And the second option is $582. It's less days, but 6 days, but you get more meals a day. So 3 meals a day. To help further analyze, which vacation is best for me, we want to find like what an actual day costs and what an actual cost per meal is. So there's 2 things we're asked to find. So we need to assign variables to those 2 things. So for cost per day, I think D is a good choice. So let's let D represent the cost per day. And for cost per meal, let's use M for meal. Let M represent the cost per meal. Now, having done that, I think it'd be great if you guys could pause the video and can you try setting up 2 equations based on each of these pieces of information that I've stuck out for you. So you can pause and unpause when you're ready. Of course, if you're following along at home, there's nothing wrong with just following along and getting it copied down. But I really would encourage you to give it a shot first. Get something down, you can always erase it. All right, let's do it. So the first option is $656. So there's several ways to write this equation. I'm going to write it this way. So 8 days, so 8 times the cost per day, plus, and if we think about it, so that's 8 days. How many meals is that? That's actually 16 meals, plus 16 meals is $656. So my anticipation is that some of you guys may put 2M, and that's like actually a really good try. This one's a bit tricky. If we think about for the whole trip, it's going to be 16 total meals, right? That's equation 1. For our second equation, and if you made that mistake in equation 1, you can pause and maybe fix up equation 2 before I write it down. So for the second equation, 6 days and 18 meals, 3 meals a day, equals 582. So just to emphasize where that came from, 8 times 2, that gave us 16 meals. So that was the hard part, guys, but now we have a linear system that's set up and ready to go. So let's copy it out, and then let's decide on a method that will work for us. So we had 8 days plus 16 meals was 656. And 6 days plus 18 meals was equal to 582. All right. So let's decide on a method, guys. So let's think about if substitution will be a good method. Is the D or the M easy to isolate in any of those 2 equations? And the answer is no. There's no easy way to get D or M by itself. So we're going to result to elimination. Is it ready to use elimination right away? No, because nothing matches. So let's match up some variables. Can we multiply one equation by a number easily to get to make variables match? Nope. So we're kind of left with our final option. We need to multiply each equation by something to make them match. So I might set it up this way, since we don't have any scaffolding. I want to make them match. So I think it'd be easiest to match the D's, because 8 and 6 are just smaller numbers to work with than 16 and 18. what could I multiply the first equation by and the second equation by to make them match? And I would say in this one, there's an okay choice, and then there's a great choice. See if you can find the great choice. You want to pause and think about that? So guys, the okay choice is to multiply equation 1 by 6 and equation 2 by 8. That guarantees you make things match, but it also makes the numbers bigger than they have to be. If you recognize that we could multiply equation 1 by 3 and equation 2 by 4, that's great because that actually gives you 24D for both of them. So 24D, 3 times 16 is 48. And 3 times 656. I definitely am going to just get my calculator because I can't do that in my head at this stage in the day. All right, so definitely left my calculator at school. That's fine. So 3 times 656, that's 1800, 1950, 1968, I believe. That's a modified equation 1. And taking equation 2, multiplying it by 4, we get 24D plus 72M equals 4 times 582. That's 2,000, 2,320, 2,328. And that's equation 2. And of course, you are hearing my dog go crazy because she hears somebody at the door. That's just the nice thing about shooting videos from home, is that just have these little quirks. And as I've said before, I don't have an editing team, so we're just going to deal with it. So I have my calculator out on my phone because I definitely want to double check these. So 3 times 656, 1968, and 4 times 582, 2,328. Okay, so I was right, but it was worth double checking. So now I've made things match, and now we can use elimination. I think it'd be best to subtract equation 2 minus equation 1 to keep things positive. The D's cancel out, and 72 minus 48 gives me 24M. And then 2,328 minus 1968 is 360. And I'm excited because it looks like I'm going to get a nice round number here. If you divide 360 by 24, I believe that's 15. But I'm going to double check. It is 15. So that's cool. The cost of a meal, $15. Let's find the cost for one day. So I'm just going to go up where I have a bit more space. We're going to sub in M equals 15. And I don't know, I'll do equation 2. I don't think it really matters too much in this one. So 6 days plus 18, the cost of a meal is 15. That equals 582. 6D, 18 times 15. Oh, I'm really stretching myself here for the with the mental math. I think that's 270, but I'm going to just double check. 270 equals 582. It's a bit of a chunky two-step equation to solve, but we can do it. 582 minus 270 is 312. And if you divide 312 by 6, you get 52. So the cost of a day is 52. So now we can make a concluding statement. It costs $52 per meal, per day, and $15 per meal. And we just used our linear system skills that we've been developing. Hardest part is probably setting it up. But now that I know that, maybe I can even custom make my own disc golf vacation. with a cost that I'm happy with, knowing the cost per day and the cost per meal. All right, so a second example in the books. In this last example, I haven't given any structure. So I'd like to see if you could possibly give it a try. So pause the video, try it on your own at home. If you're in the classroom with me, I'm going to give you a few minutes, see if you can set this one up. So remember, assign variables, set up your equations, solve the linear system, and make a concluding statement. So in this problem, Bort purchased 3 hot dogs and 2 pops at a local hockey game for $17.25. The next week, he got 2 hot dogs and 1 pop, and it cost $11. I'm asking you guys to find the cost of a single hot dog. Now, maybe I'll add in, even though this question says determine the cost of a hot dog, we'll also want to know the cost of a pop too. So we'll probably find that as we find our answer for the hot dog. This example is a lot like the disc golf vacation example. So having said that, I'm going to let you guys give this one a try. And at this point, I'm going to solve it too. So maybe you've unpaused and let's go. So, and if yours looks a bit different than mine, that's totally okay. So let's use H for hot dog. Let's let H represent the cost of a hot dog. In your own notes, if you did this, so just a reminder, if you did H equals hot dog, well, if in your mind, you know that's the cost of a hot dog, that's kind of okay, I guess, if you're practicing at home. But if somebody else is looking at that, that makes no sense. How can a variable, a number, equal to hot dog? That's the kind of math that my 3-year-old would do, right? H is the cost of a hot dog. And even if somebody said H equals hot dog on something I'm evaluating, I might say, well, what about the hot dog? Is it the cost? Is it how many hot dogs you ordered? Is it the amount of calories you get from a hot dog? Like, you have to be specific, right? The cost. And let's use P for pop. Find my cursor. Let P represent the cost of a pop. So 2 variables, done. Let's set up our equations. So let's look at the first bit of information. 3 hot dogs and 2 pops cost $17.25. 3 times the cost of a hot dog plus 2 times the cost of a pop has to be 17.25, equation 1. Second piece of info, 2 hot dogs and 1 pop. 2 hot dogs plus 1 pop equals $11, equation 2. And now that we have our linear system, let's decide on a method. So I'm looking at this one, and I see 2 strategies that would probably work pretty well. We've got a P by itself. So that means substitution would be a good choice because it's easy to isolate the P. But multiplying the second equation by 2 is also not a bad choice because that will easily match up the P's. So I would argue there's probably 2 strategies that are really good. I'm going to use substitution because I haven't used that method in this lesson yet. So I think just to refresh ourselves. So let's rearrange this. So the cost of a pop is negative 2h plus 11. That's just rearranging equation 2. And I have space up here. Actually, I'll start. Where do I want to start? I think I'm going to start where I have more space. I'm going to go up here. I'm going to sub equation 2 and equation 1. So 3 times h plus 2 times the pop is minus 2h plus 11 equals 17.25. So let's solve this equation, guys. We have some brackets, got to multiply in that too. So 3h minus 4h plus 22 equals 17.25. 3h minus 4h is negative h plus 22 equals 17.25. Subtract 22 from each side. It looks like you get negative 475, negative 4.75, which means that h equals positive 4.75. So we found the cost of a hot dog by solving that equation, 4.75. That's great. Now let's find the cost of a pop. So I think I will squeeze my work in. If I can find my cursor again. I'm going to sub that into our rearranged equation. So sub it in 2. So the cost of a pop is -2 times 4.75 plus 11. That is -9.5 plus 11, which is positive 1.5. Put the p's there. Now I can make a concluding statement. So a little, therefore, a hot dog costs $4.75. And I should say, like, honestly, if you just look at the original question, you're asked to find the cost of a single hot dog. We could have stopped after finding H. We could have stopped. Just for completeness sake, though, we found the cost of a pop too. And a pop costs $1.50. All right. And that's easy to check. You could just check. So 2 pops is $3. 3 hot dogs is $14.25. Adds to $17.25. 2 hot dogs is $9.50. Add $1.50. That's $11. So I took 10 seconds. I did the mental math. Or if you're unsure, take a calculator. Take 30 seconds, and you can check your answer here. So one last time, guys. The steps when problem solving with linear systems are always the same. What's the problem asking you for? Assign 2 variables. Take the 2 pieces of info in the question, make 2 equations. Solve the linear system, write a concluding statement. And at this point, we need to practice. So we will practice with these types of problems. In our next lesson, our final lesson for this unit, we're going to look at some more types of application problems, including mixture problems and speed, distance, time problems. But until then, hope you're staying well. Have a great day. Thanks for persevering through all the hiccups in this video, and we'll see you guys soon.